coming in from this side this time. You ain't never gonna know. I'm not always gonna come in from this side of the camera anymore. I don't want to be too damn predictable. All right, I gotta get my energy up. I'm feeling a little tired today. That's why I gotta put some music going here, man. Come on, work with me. There it is. Oh, mercy. Hey, we got special right triangles again. Let me draw one. Oh, there it is. All right. So time to get a little serious. I'll turn down the beat just for a moment. Just for a moment. Don't you dare make me turn them off forever. All right, so let's go. Hey, I just made a video. I don't know if you see that if you check Special Right Triangles video 1, I'm wearing the same thing because I just made the video, but I thought it was getting a little long, so I want to start over. But look, this is the case I didn't go over right here, right there. This is the one that always gets the students. It's when you're given the altitude, or you're given, I guess, or what we've been calling the long leg, the leg. Remember, the legs of a right triangle make up the 90-degree angle. And in a 30, 60, 90, there's always going to be one leg bigger than the other leg. Because the only time the legs are the same is if the angles are the same. Now, because 60 degrees is bigger than 30, we know that this side opposite the 60, right? Because the 60 opens up to a bigger side than say, the 30 will open up to. Then this must be our short leg. So you've got options here. I want to go over just a few of them. Option number one, I might just speak in a slightly deeper voice here, sound more commanding, is that you can't just remember the relationship between the short leg and the long leg is times √3, because the long leg is longer, so it's not, this number is bigger than 1, so you're guaranteed now this will be a bigger number than this. And you can remember that this is a times 2. And so what does that mean, right? What it means is that if you multiply something by 2 to get to here, then to go the other way, which I'll show in purple, you must times by 1 over √3. Now multiplying by 1 over √3 is the same as dividing by √3. And similarly, I got little arrowheads here. When you go the other direction, you must be timesing by 1/2. So that's option number one. You should always, again, I would just write H, so I'm kind of getting zoned in to what the hypotenuse is. So now what you could think is that this must be 12 times 1 over √3, which is 12 over √3. Done. So this is 12 over √3. Now I'm not rationalizing that, but if you do rational, maybe I just will. I'll go like this. I talk about this method of rationalizing the denominator in another video, and there's lots of other videos too that talk about the same thing. And so that gets us to 4 √3. So two answers. They're both fine. Okay, they're both. Your teacher probably wants this one, look. So now we're here at the short leg. So let's take 4 √3 or 12 √3. I'll just do them both. Okay. So from here to here is the doubling. That's always the ratio of the short leg to the hypotenuse. So if this is 4 √3, this must be 8 √3 or 24 over √3. You just double it. So when you multiply 4 √3 times 2, it's just basically 4 times 2 is 8, and the √3 is the √3. And the same, when we multiply that by 2, 12 times 2 is 24, √3 times 1 is √3. Okay, so there you go. Those are one option. The other option, which is kind of more of a formula approach, and a lot of students like formulas, so let me show you another option. I'll just pick another number. Let's try this one. Let's go here and here. Okay, so this is my 60, and again, I'm going to give you this. So I'm giving you the long leg. So step number one, we're going to identify the hypotenuse. We're going to identify the long leg and the short leg. You always got to do step number one until you don't have to do step number one. Mr. Miller, do I got to show step number one? You do if you need to. If that's what you got to do to make sense of the problem, then I say go ahead and do that. Nothing more, nothing less. Nothing more, nothing less. Now, here's what I like. I never used to even teach this, what I'm going to show you right now, but some students gravitate towards it. So the ratio of the long leg to the short leg is root 3 over 1. And then they'll call that, say, x and y. And then they'll say, well, that's equal to, the long leg is 20, and the short leg is x. This gives them something to cross multiply. So that gives me root 3 times x is equal to 20. Now what we're going to do is we're going to divide by root 3, because that means those are going to cancel or reduce to 1. And so that gives us x is equal to 20 over root 3. Check. So this is 20 over root 3 now. So I'll go over here and write 20 over root 3. You might need to rationalize this, which means you don't want the radical in the denominator. So you multiply top and bottom by root 3. That gives you 20 root 3 over 3. And that's not very fun. That didn't cancel nice and pretty like the last one. So I'm just going to leave it like this. Now the hypotenuse, so you have to double it. So I'm going to go 40 over root 3. Done and done. Check and check. So that's one way to roll with these. I've seen students have lots of success by just the first thing they do is not only do they show the hypotenuse, the long leg, and the short leg, but then they also just kind of do this thing that I show you here where it just kind of sets them up. It sets them up for the relationship. So they know that from here to here is times root 3, and so to go the other direction must be times 1 over root 3. Okay, well, hey, I'm real stoked with that. Let me give you one more. I don't want you to leave here empty-handed. God, no, I don't want that. So let's go boom, 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 and go this way. All right, so this is how I'm going to orient the triangle. I'm going to give you the 30. And then right here, I'm going to say that this is 12 root 3. All right, x and y. Solve for x and y. Hit pause right when I throw these markers up, because that'll be cool and it'll look like the markers are suspended in air. Ready? Hit pause in 3, 2, 1, pause. Okay, if you did that, that is going to be awesome. Awesome. It's awesome. This is so awesome. Okay. You got a good life. All right. That was my best. Forget about it. Let's move on. All right, so what am I going to do? You know, it's rule 1. Rule 1 for us has been, let's just find the hypotenuse. Let's just make sure we've got this triangle oriented properly. Long leg, short leg. I know this leg is longer than that because it's opposite a bigger angle than that one. All right, so now, one thing I might do here right away is notice that that's a times root 3. And if I'm going to multiply by root 3, and I'm going to end up with 12 root 3, then I must be starting with 12. The answer has to be 12, because 12 times root 3 is 12 root 3. Now, from short leg to hypotenuse, that's a times 2. That's a 24. Okay, so that's a really cool way of doing it. I like that way. Let's go the formula approach. Let's go long leg over short leg is root 3 over 1. In this case, we knew the long leg was 12 root 3. The short leg was x. Now we're going to set up a cross multiplying. That gives me x times root 3 is equal to 12 times root 3. Let's divide. So those cancel or reduce to 1. And that gives me x is equal to 12. All right? So that's how you can do those. Or, you know, remember, if you know that you're multiplying by root 3 to go that way, then you must be multiplying by 1 over root 3 to go the other way. And you could say 12 times 1 over root 3. It's 12 root 3. 12 root 3 times 1 over root 3. Those cancel, and you're sitting there with your 12. Boom, 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 boom. Boom. Remember, special right triangles, the whole reason that this beautiful thing is special, and this will take me one more minute just as a reminder, is because look what happens when you reflect it. You get an equilateral triangle that's 24, right? That's 12 because this is 12, which makes this 24. If that's 60 upon reflection. If that's 30, that's 30. So now I have 60, 60, 60. Equilateral triangle, so beautiful and so special. And then the reason all these ratios work is because equilateral triangles are always similar. And so 30, 60, 90 triangles are always similar. So whatever the ratio is from the short leg to the long leg, it will always be that way. It'll be that way today. It'll be that way tomorrow. It'll be that way on Tuesday, even on Tuesday. All right, so I used a sign off last video. I think I'm going to go back to it before I go because I never know what to say last. So I kind of like that guy, Ralph Barbieri, used to say this. I'll just repeat it, that remember, angels fly because they take themselves lightly. Mic drop.